Welcome back to Outside Views Military, where we peel back the layers of Cold War engineering to see what would have actually happened if the peace had been broken. And today we're diving into a very specific and lethal technical comparison that was central to the survival of the European theater: the neutralization of airfields. To stop an enemy's air force, you don't necessarily need to shoot down every plane, you just need to make sure their runways are unusable. The NATO answer was the Panavia Tornado, equipped with a massive MW-1 dispenser, while the Warsaw Pact often relied on the brute force of the Sukhoi Su-22 firing S-24 heavy rockets. But let's start with the German multi-purpose weapon, the Mehrzweckwaffe 1, or Mehrzweckwaffe 1 when I say it in German, or simply the MW-1. The MW-1 wasn't just a bomb, it was a complex 5-ton sub-munition dispenser that stayed attached to the Tornado throughout the attack run. It consisted of 112 lateral tubes designed to fire a mix of specialized payloads out to the sides as the aircraft thundered across the runway at Mach 0.9. The primary weapon for runway denial was the Starbo, or Startbahnbombe, a two-stage masterpiece of destructive engineering. As the Tornado swept over the target at an altitude of just 50 meters, the MW-1 would eject the Starbos in a precisely timed sequence. Each Starbo was parachute retarded to ensure it hit the concrete at a near vertical angle, which is critical for penetrating hardened surfaces. And the first stage of the Starbo was a shaped charge that used the Monroe effect to burn a narrow channel deep into the concrete and the underlying soil. A millisecond later, the second stage, a high explosive blast charge, was propelled down that same channel to detonate deep beneath the surface. And this created a massive underground void, causing the concrete above to heave and to crack into jagged, uneven slabs that were a nightmare to repair. The MW-1's true genius, however, lay in its area denial submunitions like the Muspa, which were scattered alongside the cratering charges. The Muspa was an intelligent mine equipped with acoustic and seismic sensors designed to detect the sound of bulldozers or repair crews. If a repair team approached the craters, the Muspa would detonate, shredding tires and personnel with thousands of steel pellets. This meant the MW-1 didn't just break the runway, it turned the entire airfield into a lethal trap that could stay closed for days. In a single pass, one Tornado could lay down a strip of deconstruction, almost, but it was a strip of destruction, roughly 800 meters long and 180 meters wide, covering the entire width of a standard Soviet-style runway. And now, contrast this with the Eastern philosophy embodied by the Sukhoi Su-22 and its S-24 rockets. The S-24 is a 240mm unguided rocket, essentially a flying artillery shell with a 123 kilogram high explosive fragmentation warhead. While the Su-22 could carry dedicated concrete piercing bombs like the Betap 500, the S-24 was the go-to weapon for suppressing airfields due to its versatility and high velocity. The Su-22 pilot would typically approach the target in a high-speed dive or a low-level level flight run using the S-17 optical sight. The S-24 relied on pure kinetic energy and blast force to damage the runway's surface. A direct hit from an S-24 would certainly create a significant crater, but it lacked the sophisticated heaving effect of the Starbo's two-stage detonation. Furthermore, as an unguided rocket, the S-24's accuracy was dependent on the pilot's skill and the stability of the aircraft during the launch. The Su-22 would have to fire its rockets in sticks or salvos to ensure enough coverage of the runway, often requiring multiple passes to achieve the same effect as a single Tornado. Each pass over a heavily defended NATO airfield, protected by Rapier missiles or Gepard flak tanks, was a roll of the dice for the pilot. The SU-22 was armored, yes, but it didn't have the Tornado's automated terrain following radar to hide it in the folds of the earth at night. And this highlights the fundamental difference. The MW-1 was a precision instrument designed for once-and-done surgical strike. The S-24 was a flying sledgehammer, a tool for war of attrition where the goal was to saturate the target area with high explosives. And if we look at the pure effectiveness for runway denial, the MW-1 wins hands down because of the Starbo's ability to destroy the runway's foundation. Repairing a simple hole from an S-24 is a matter of filling it with gravel and pouring fast-setting concrete. Repairing a heaved starboard crater requires digging out the entire foundation. However, the MW-1 had a massive Achilles heel, the direct overflight requirement. To use the MW-1, the Tornado had to fly directly down the length of the runway, placing it in the teeth of every short-range air defense system on the base. And this led to high loss rates for British Tornadoes using the similar JP-233 system during the early stages of Operation Desert Storm in 1991. The S-24, while less effective at denial, could be fired from a standoff distance of a few kilometers, allowing the SU-22 to break away before entering the inner ring of flak. In the end, the MW-1 represented the high-risk, high-reward nature of NATO's quality over quantity strategy. It was a weapon that could paralyze an entire air division in 1 minute, provided the pilot was brave enough or desperate enough to fly through a wall of fire. The Su-22 and the S-24 were the pragmatic response, simpler to build, easier to maintain, and capable of being used against a wide variety of targets beyond just runways. The Tornado's MW-1 was eventually phased out as the world moved towards standoff precision-guided munitions like the Taurus or the Storm Shadow. But during the 1980s, the shadow of a Tornado carrying 2 MW-1 pods was the single greatest nightmare for any Soviet airfield commander. It was the ultimate expression of specialized precision, a tool built for a very specific job that did it better than anything else in history. The SU-22 and its heavy rockets remind us that sometimes sheer brute force and a willing pilot are a strategy all their own. But fortunately, we never had to find out the full capacity of those. But thanks for joining me for this little dive once again on Outside Views Military. The Cold War was won and lost in these small engineering details, from the timing of a shaped charge to the blast radius of a 240mm rocket. But make sure to subscribe so you don't miss our next analysis of the machines that kept the world on the edge for 40 years. Or the newest of the new that is bringing us away from the next one, because as many people say, we are kinda in a new Cold War today, and honestly, I at minimum want that to end like the last one.